We're into chapter 6, and you have an extensive list of rules of exponents in your notes, and you should review all of those. You could need them at any time, but we're going to work a few here to highlight a few of those rules. So let's first simplify this expression that contains exponents. Right, we have the expression negative 5m to the 4th power to the 5th power. Okay, and remember, a rule of exponents says that every factor inside the parentheses gets the power outside. So if you need to think of these as separate factors, negative 5 is a factor, m to the 4th is a factor. They get the power 5. So it may help you to rewrite negative 5 and show that it gets the 5th power. Okay, and m to the 4th and show that it gets the 5th power. Alright, and then in order to simplify that, we're going to think through the sign of this. This is a negative number raised to an odd power, so we know the result will be negative. And then you might, in your calculator, multiply 5 times in a row. That will give you 3,125. Alright, and then we need a rule of exponents here for m to the 4th raised to the 5th power. That's the power rule. One base raised to 2 powers. We multiply these exponents to get m to the 20th. Okay, let's look at another one. Sorry about that focus problem. I'm not sure what to do about it. Let's take a look at this one here. Negative 5m to the 4th. We'll put the 5th power inside and the 4th power outside. How does that? How will that change anything? Well, we still know that the factor negative 5 this time gets the 4 power, and the factor m to the 5th also gets the 4 power. So it won't change much, but it will change something significant. This time we're raising a negative number to an even power, so we know the result will be positive. And then you might want to put 5 in your calculator, multiply it 4 times. That gives us positive 625. Now, m, again, this is one base to 2 powers, so we know we're going to multiply those powers. Again, we get m to the 20th. And let's take a look at this expression. 2a to the negative 3, b to the 6, a numerator, and then a denominator, 4a squared, b to the negative 3, and we're going to raise all of that expression to the negative 3 power. So we have a lot of rules that we need to follow here, and we have some choices about how to follow, what order to follow those rules in. This is negative 3 power. We could flip this immediately and change that to positive 3, but remember that that's taking care of an exponent, and inside the parentheses there's work we can do. So it would be a good idea to do work inside the parentheses. So let's see what we can do inside the parentheses before we take care of the exponent outside. 2 over 4 simplifies to 1 over 2. Remember, we could divide 2 and 4. We could simplify that fraction. And then remember, there's a shortcut to saying I have same bases a in the numerator and denominator. The one with a positive exponent stays put, and the one with a negative exponent needs to trade floors, doesn't it? So it comes down here. Alright, now what do I have left here? I have b to the 6th in the numerator to stay put, and this b to the negative 3 from the denominator needs to trade floors to the numerator. Okay, now we have all positive exponents inside. We could still do some work inside, couldn't we? Because we could use the product rule here. So let's simplify inside still. This is 1 times b to the 6 times b to the 3. This means we add the exponents. 2 bases multiplied. It's the same base. with 2 powers. So that gives us b to the 9th, and this gives us 2 a to the 5th. Alright, at this point it might be worth trading floors. Alright, so we can make this a positive 3 power now if we trade floors inside. 2a to the 5th, b to the 9th. Okay. Alright, what remains to be done? Well, this is much like one we did here earlier. Every part of the parentheses gets the power 3. So the numerator, both factors get the power 3. So we could say 2 to the 3 power and a to the 5 gets the 3 power. And the denominator also, b to the 9, gets the 3 power. Now we have more rules. We can go ahead and apply the 3 power to 2. Okay, so that's 2 cubed, or 2 to the 3rd power. 2 times 2 times 2 is 8. We use the power rule here, 1 base to 2 powers. Okay, that means that we multiply the exponents for a to the 15. And then same thing here, b, 1b base b to 2 exponents to 2 powers. We're going to multiply those powers, b to the 27th. Alright, and then we don't do anything with these exponents here because these bases are not the same. 8 has nothing to simplify with in the denominator, so we consider that simplified. Let's do one more here. Now let's simplify this expression. 15 x to the 5th, y to the negative 7, over 5, x cubed, y cubed, and let's raise that entire expression to the negative 2 power. Okay, this one will work much like the other one, won't it? Is there work we can do inside parentheses first? Yes, 15 over 5 reduces. Both of these will divide by 5. So think of dividing 15 by 5 and 5 by 5. That would give you 3 over 1. And then x to the 5 and x to the 3, nothing needs to trade floors, okay? So x to the 5, x to the 3. Now y to the 7th needs to trade floors. It needs to, so y to the 3 here stays put, y to the 7 needs to travel down to the other floor. Still have a negative 2 power here. Alright, what else could be done now? Well, I could apply the product rule here, so let's do that. Now you may combine some of these steps. I'm just trying not to go too quickly to leave anyone out. So I would go ahead now and leave the 1 factor understood and make this x cubed, and use the product rule here to make this y to the 10th. Still haven't taken care of that negative 2 power. What else could we do? Is there any other rule that applies inside the parentheses? Well, yes, I believe so. Remember, we have same bases in the numerator and denominator. That means we could subtract these exponents. Alright, so what would that give us? X to the 5 minus 3. So let's cancel this, make that 5 minus 3. Alright, let's go back here and rewrite this now. In parentheses, we have a numerator 3x squared, that was our 5 minus 3, over y to the 10th, and we have the negative 2 power still outside. So now I believe let's go ahead and take care of this negative 2 power. No more work to do inside. Let's make that a positive 2 power by trading floors here. Y to the 10th to the numerator, 3x squared to the denominator. And now remember that every factor here gets the 2 power. So it may help us to see y to the 10th gets the 2 power. 3 gets the 2 power, and x squared gets the 2 power. Okay, now we might simplify all of this. This is the power rule, 1 base y to 2 powers, we multiply those, y to the 20th. 3 to the 2 power, or 3 squared, is 9. 1 base x to 2 powers, we multiply those for x to the 4th power. So that simplifies at y to the 20th over 9x to the 4th. That's a good review of quite a few of the rules of exponents.